Hello, my name is Neil Patel, and I'm half the Type Foundry Jammer Patel. And today I'll be talking about a couple of African scripts, the level of support they have found in technology, and the impact that has had on the respective language communities. Our involvement with African scripts started back in 2014, when we set out to develop a typeface family that covers the most prominent writing systems of Africa. This family was completed in 2018 and is named Kigelia. The intent was to create a well-researched type family that offers a range of typographic expression for writing systems that to date had maybe only one to a small handful of typefaces, often in one style. So where appropriate, the system includes italic styles for some of the African scripts. The need for a breadth of styles was clear. The fonts that are out there in their single weights, while suitable for basic documentation, did not provide for the ability to create information hierarchy required for documents, digital content, or user interfaces. As we were developing this type system, we found that two of the scripts were facing higher barriers to being usable in computing, barriers that an extensive type family could not alone solve. Unko and Adlam are both writing systems from West Africa that have not enjoyed 1,000 years or even 100 years of broad use. That means, unlike older writing systems, these scripts were coming of age in the desktop and mobile computing era. So let's take a quick look at each of these scripts. The Unko script was invented by Suleiman Kante, a merchant and autodidact born in Guinea in 1922, in order to provide a written form for Manding, which until that time was primarily oral, although it was written occasionally using the Latin and Arabic scripts by religious and secular scholars. Kante finished his development of Unko in February of 1949. The Mande consists of a group of 40 million people that live in an area that spans from Mali south to the coast of West Africa. Unko supports the Manding languages of Bambara, Maninka, Jula, and Mandinka. The Unko writing system is a connected right-to-left script that marks tone with diacritics. Adlam was invented by two brothers, Abdullah and Ibrahima Berry, in the 1980s as teenagers, when they discovered that their own language, Pular, lacked its own writing system. They've been actively improving it, promoting literacy, and creating education material for the Fulani ever since. Pular, also called Fulfulde in the East, is a macro language that belongs to 50 million Fulani people that live in the sub-Saharan region of Africa spanning from the west coast all the way to Chad. Adlam is also a connected right-to-left script that marks gemination with diacritics as well as modification of consonant sounds for loan words. While both Manding and Pular can be written using the Latin script, there are a number of distinct advantages to using Unko and Adlam. Because both populations diverse in a number of countries, the Latin-based orthography can vary nation to nation. And though there are consolidated standards that exist for both these languages, some of the variation in orthography is caused simply by governments trying to maintain a unified character set that covers all the languages within their countries. Unko and Adlam standardize both the orthography and spelling practices that would otherwise be present across different dialects or regions. So you can see in this Unko column, this G sound, which will vary in how it's pronounced, whether you're in Mali or in Guinea, is represented by the same single letter. Similarly, with the Adlam column, you can see different ways of writing the same sound in Latin that can vary by region or region, all get represented by one single letter. And in the case of Manding, the co-writing system has the added advantage of marking the tonality of the language. This is not done with the Latin-based orthography, requiring the reader to determine what is being written via context. Okay, so now that we're a bit familiar with Adlam and Unko, let's focus on the internationalization efforts around them. This is a workflow that's familiar to most people in this audience. It's a sequence of events that need to occur to bring a new writing system into computing. And it typically starts with a proposal for encoding, and then after a period of time of research and demonstration of stability and breadth of use, it becomes encoded. This is followed by development of fonts, and then some work to have operating systems actually be able to shape those fonts. And then after a period of time, input methods are developed to allow a user to actually interact with the device. And this is typically followed by propagating the CLDR database so that apps can be localized in that writing system. Okay, so let's look at the onboarding history for both Adlam and Unko, starting with Unko. Unko was initially proposed for encoding in 2004, and then by 2006 it was encoded officially in Unicode version 6. The next major development was the addition of Unko to Microsoft's Ibrima UI typeface. Then there was a kind of a gap of 6 years where nothing happened till about 2013 when No Sans Co was released by Google. So after about a 2-year delay, we see a flurry of activity in 2015. And this is when Windows 10 was released with universal shaping engine support for NCO, and there was also included a virtual key layout for it. Shortly thereafter, Apple and Android included shaping support as well and had bundled in NodoSens NCO. But neither of these operating system updates included an input method. And the situation changed by the end of 2018 when Android finally released an NCO keyboard. iOS and macOS still don't have a keyboard, but all in all, we can see that about 15 years after NCO was initially proposed, that you have some basic usability across all major platforms. Now let's turn our attention to Adlam. Adlam, of course, is a much younger script, and it was only proposed for encoding in 2013, and that was subsequently granted in 2016 in Unicode 9. Adlam was able to benefit from operating system improvements going on at the time. So within a year of encoding, shaping was supported across all major platforms. After about a year and a half, we start to see system fonts being released for both Windows and Android. And unlike NCO, Google was able to include Android keyboard for Adlam only within a year after adding it to Nodo. And as of a couple weeks ago, Apple has included NodoSens Adlam in iOS 14. So overall, getting Adlam to the same level of basic usability as NCO has only taken about 7 years. So as of today, this is what support looks like for both these writing systems. On Android and Windows, both of these scripts are very functional, and the shortcoming on iOS and macOS, of course, is because of the lack of input methods. Now, I should point out that in reality, the situation is better than this. Because of third-party apps, fonts, and keyboards, some of which that we've created, you're actually able to use both these writing systems on all operating systems in some capacity. And this has been the case historically. Whenever there's been a delay in an operating system releasing its own keyboard, the third-party solution has been there to bridge the gap. Now, if we look at CLDR coverage, Adlam's doing pretty well. It actually has comprehensive level coverage. And as of this year, working with a small team, we're able to get core data propagated for NCO along with a few other categories. Overall, most of the steps of our onboarding workflow have been completed. And if we're to use the completions of these steps as a measure of success in saying we've created a basic level of language support, then we're pretty close to crossing that milestone. In reality, though, fonts, shaping, and keyboards, these are just the building blocks of being able to compute in any given language. What really matters is how well these tools can be applied by a language community in a way that's meaningful to them. I would propose that a more accurate way to assess the effectiveness of internationalization efforts is to look at a series of functional milestones. These milestones give a better measure of how well a language community is thriving. Browsing is the most basic of these, and really all it shows is how easily information can be consumed by a community. Messaging is interactive, and it's really about day-to-day communication. Content creation takes us one step further. So this is going beyond, the short form casual conversation to something more long form, in depth, and more complex ideas. Math and science is arguably a subset of content creation, but its needs are very particular, and it represents a more complex type of thought. And then finally, bibliographic cataloging. It demonstrates how well the ideas a community create are collected to build a legacy of thought. So let's take a look at how well technology is functionally enabling the Monday and Fulani communities. And so we'll start with browsing. So this is not an exhaustive look at all browsers on all platforms, but kind of a quick look to see how well things are performing. And for general websites, both desktop and mobile browsers render Adlam and NCO pretty well. Interestingly, what we see on mobile browsers for Facebook content is that it's incorrectly aligned. But like I said, this does not apply for general websites. On the desktop version of Safari, we do see the text alignment issue as well. But overall, again, this is not bad. The majority of users are able to consume any content they encounter online. And despite some of these issues with Facebook on mobile browsers, this is not really an issue if you're using the Facebook app. When it comes to messaging, again, things look pretty good. Text messaging and apps like Telegram and WhatsApp all render both scripts properly. And this is, largely unsurprising. If the mobile operating system can properly render these scripts, then the standard text field element used to build these apps should do so as well. I should point out there's efforts ongoing right now to localize the Telegram app in both Adlam and NCO. Moving on to content creation, the most common tool to use is our word processors. And what we're seeing here looks pretty good. All major word processors are rendering both of these scripts properly. Text alignment is looking good, as well as mark attachment. The one exception is the Mac OS port of Word. You can see here with Odlum, it's having trouble with attaching the marks. Another thing that we see is an issue with font fallback when you use Arabic punctuation. In Odlum, you would close a question using the Arabic question mark, but what happens is it switches over to a system font, and then that system font kind of gets used afterwards, unless you go back and change it. The next step up from word processors is publication design software. So if you really wanted to typeset a book or a scholarly journal, you would use something like Adobe InDesign. And in the past year, its ability to render Odlum Unicode has gone from serviceable to completely unusable. In the 2019 version of the software, you could get the script connection to work, but you did have to manipulate the font and how the language tags are assigned. And then you still have to do a certain amount of manual cleanup to get the word boundaries to look right. This situation changed in 2020 with the new version of InDesign. Now the script connection is completely jumbled up, marks are failing to attach properly, and if you want to attempt any sort of manual cleanup, it's not possible because you can't even select a portion of text. In addition to being able to produce print documents or standalone digital documents, there has to be the ability to publish content to the web. And until recently, when iOS 14 finally added Noto-Sans Odlum to its font set, there was no way to reliably see Odlum web content across all platforms. So in order to accomplish this, you had to embed the font onto a website, which is what you're seeing here on the left. But modern WYSIWYG website builders have made it much easier to use web fonts, and that's just something more likely that the average person would choose to do. But as of today, you currently can't get the Noto-Sans Go or Odlum fonts on the Google Font service. The other important medium for content creation is video. And with literacy rates being low in West Africa, this is particularly important. And you do see a lot of Monding and Pular videos on YouTube. Unfortunately, the YouTube console doesn't allow you to choose either Pular or Monding in its language classification menu. And this same limitation is seen in the video subtitle menu as well. The only workaround is for the user to select Japanese as the subtitle language of the video, and this subsequently allows them to upload their own custom subtitle file in any language or script that they want to use. So this lack of support forces users to use a workaround that misclassifies the videos, and while it satisfies the needs of the language community in the short term, it likely fouls up how these videos are also sorted on the back end. The ability to use math in Go and Odlum is extremely limited. And there's no spreadsheet program that recognizes their numerals as numbers. And so while you can build tables in spreadsheets, there's no way to apply equations to them. And what this means is that spreadsheets can't be used to analyze data or perform business management tasks. Similarly, the ability to document math is also not possible. In both scripts, equations need to run right to left, with mathematical symbols, like the square root symbol you see above, needing to be mirrored. And while most mathematical symbols are defined in Unicode as something that can be mirrored, there's no straightforward software implementation to do this. This makes creating educational and scholarly material on topics of math and science very difficult. If we look at the digital cataloging systems used by libraries, we have a mix of encoding support. The Library of Congress uses their MARC system. MARC 8 is the older encoding system that's based on ISO 2022, which is very limited in its language support. MARC 8 was essentially frozen in 2004. MARC 21 was introduced as an update to MARC 8, and it supports full Unicode encoded as UTF-8. This update allows the Library of Congress to make bibliographic records on a large breadth of materials written in different scripts. However, the authority records, which track names, subjects, as well as cross-referencing information, is limited to MARC 8 encoding. The OLC system, which is used by WorldCat, uses Unicode encoded as UTF-8 for both the bibliography and authority records. However, its support is currently limited to Unicode 6. As a result, our ability to properly catalog Odlum and Unicode documents is incomplete, with the situation being somewhat better for Unicode. And this is problematic, because one of the whole points of encoding is effective document preservation. So if these documents can't be cataloged and then subsequently retrieved or referenced to other documents, then their ability to be beneficial to people is limited. So if we made a qualitative assessment of these milestones, I think we can see that language support for Odlum and Unicode is still very basic. Certainly software services have gained users as a result of the efforts, but it would be a stretch to say that these language communities have been enabled. And I'm certain some of these gaps will be closed at some point in the future. However, considering that UNCO users have waited 15 years to get to this stage, can we say that the onboarding process was effective or worth the wait? Maybe the argument could be made that given all the work that had to happen to get to this point, that the 7 years taken to onboard Adlam is a sign of improvement. However, much of the decrease in time was made from efficiencies created by the fact that the software changes needed to make UNCO work directly applied to Adlam. It's very likely that if Adlam were also encoded in 2004, it would have taken the same amount of time as UNCO. I think to understand this a bit better, it's worth drilling down to the 6-year gap where there were no developments in UNCO. If we look into this time frame, we see the disruptive change of the industry pivoting from desktop computing to mobile computing. As UNCO was being encoded, both the iPhone and Android were released. Prior to this, Professor Baba Mamadi Diané, a leading UNCO activist, was working on a DOS-based word processor at the University of Cairo. Unfortunately, these efforts were not ultimately fruitful because of the compatibility issues and complexities of implementation. Desktop computing was also not something that was readily available or accessible to the masses in Africa, so the impetus to make his word processor work was pretty low. In the end, the arrival of mobile computing began a shift in technology that ultimately gave more people access to the internet. And during the period of time between 2010 and 2012, the installation of an undersea fiber optic cable for data helped further the spread of mobile technology in Africa. This is certainly a worthwhile advancement, but the process of upscaling the novel smartphone technology, along with other priorities, resulted in a pause in increasing desktop support for UNCO. In light of this, I think it's fair to explore this question: when does technological progress become counterproductive to internationalization efforts? I think it's important to remember that infrastructure improvements in West Africa lag behind the pace of improvements in technology. For example, while mobile broadband coverage is quite good, the bandwidth of that coverage is quite low. Most of it's operating at 2 and 3G. And the cost of that broadband to the user is quite high. For comparison, that red line on the chart is the percentage of gross national income per capita that mobile broadband costs Americans. The discrepancy in expense for Africans is quite substantial. Data is also bought in a prepaid fashion, so there's a lot of SIM card swapping and shopping for deals. So if you combine these factors, you end up with users choosing to turn their data on and off as needed to conserve it. An impact of this is that it's difficult to roll out app updates to all users in a timely fashion. This is a look at the adoption rate of one of our keyboard apps. This shows an app release that we had made in April of 2019, and that's marked as version 1.9. And that initial drop you see in version 1.7 adoptions are those users that had moved up to 1.9. However, a large group of users continued to use version 1.6 and 1.7. So not only does this take months to get users onto the latest version of an app, a lot of users choose not to update at all. And this makes rolling out bug fixes and feature adds incredibly difficult. This is exacerbated by the fact that OS updates are slow to reach users. Part of the issue is related to the limitations that users are putting on their data consumption, but also the fact that the affordable phones that are popular in Africa often don't push Android updates for a long time after they're released. It takes a year plus for the majority of users to be on the latest OS. Regardless, a large number of users will still be using older generations of the operating system. So if you're a user waiting for a keyboard app that was to be released in like a new version of Android, you might be actually waiting quite some time before you actually see it. As mobile technology is moving to be more reliant on constant connectivity and software moving more towards subscription-based models, increasing the gap in technology and the user in West Africa is widened because these things rely on more robust infrastructure. It's one thing not to have access to a new feature, but it's a different thing if a technological advancement undermines a language community's efforts to proliferate the use of their script. Like most language groups in West Africa, the Mande and Fulani are distributed across multiple countries, each with a different ethnic makeup. This, combined with an assortment of socio-political dynamics, means that neither group enjoys state-sponsored education of their respective writing systems. Everything is done at the grassroots level. Therefore, the ability to leverage computing and the internet is integral to that mission. To get a sense of what areas are best to help facilitate the use of UNCO and Adlam, one just needs to take a look at what's being currently done. If you were to look online, you would find relatively few web pages. There's about 5 UNCO websites and about 2 in Adlam, and all these sites are geared towards news and current events. We see a lot more activity on Facebook, There are about 38 pages that feature Unko prominently and about 19 that feature Adlam. And these pages include both group pages and public individual pages. And this makes a lot of sense since making web pages is more difficult than posting content to Facebook, and this is particularly true if you're working from a mobile device primarily. There's also a lot of YouTube accounts. I was able to find about 20 Unko accounts and about 10 for Adlam. And this also makes a lot of sense because, as we mentioned earlier, the overall literacy rates are low. And these YouTube pages are a mix of news and educational content, but what's interesting is they often feature titling, captioning, and graphics in Unko and Adlam. But the real activity is occurring on peer-to-peer messaging apps. And typically these consist of large chat rooms that range from hundreds to over 1,000 members. And these groups are a place to exchange thoughts and post audio files about topical information. A subset of people are using desktop computers to create market edition prints of books and newspapers for local distribution. And if you look at the typefaces that are being used, these are ones that were created pre-2010 and predate a lot of modern improvements. And in the case of Adlam, I can see many of the publications are using a typeface that predates encoding altogether and uses Arabic code points and a very early design of the script. One of the most notable things you'll see when perusing social media pages is how prevalent posts centered around literacy are. When new lessons come out, you'll often see them pop up on most of the other pages. There are even postings that advertise services for personal lessons. Similarly, if you look at the most popular Adlam and Unko apps outside of keyboards, all of them are geared towards literacy and education. In a nutshell, it's very clear to see that these language communities are first and foremost looking to promote literacy and develop information pathways that are independent and culturally relevant. Therefore, when technology fails to make it easy to create, find, and distribute this content, it undermines this activity, and it does a disservice to internationalization efforts and the language community. And while the slow progress of language support is concerning, what's often more concerning is when technological updates create new barriers. For example, in recent iOS and Android releases, both operating systems closed pathways that allowed users the ability to sideload fonts. And while these decisions make sense from a security and IP protection perspective, it also limited the ability of users and third parties to bring language capabilities to devices that were not being supported by OEMs. Along these lines, another shortcoming that we're contending with is incomplete support for third-party input methods. The addition of system font for Adlam in iOS 14 is a great development. However, without an OEM keyboard, users are reliant on third-party solutions. Unfortunately, virtual keyboard key maps don't port over to a attached physical keyboard. Recently, we had a user of our Unko iOS keyboard app lamenting the fact that he could not use a physical keyboard on his iPad Pro to type Unko. This is a similar issue facing Adlam. Apple currently doesn't offer the ability for third parties to create these key mappings for physical keyboards. The only provision is to define the NS extension attribute's primary language tag in your keyboard extension, and this tells the system which of the available key layouts a physical keyboard should use. However, without an OEM key layout defined, this parameter cannot be set properly. In this example, the app validation fails if you try to use the BCP47 value of ff-adlam for this tag. So once again, we have this improvement that creates a new gap that cannot be solved by third parties. Another place we see regression is how evolving App Store policies are not sensitive to a variety of international norms, and this has affected some of the apps that we distribute through the Google Play Store. In January of this year, we were notified that 2 of our 3 calculator apps were being pulled for violating repetitive content policies. The notice did not offer details exactly on how our apps were violating the policies, but they did provide links to the policy language. These policies are very vaguely written, but looking at the list of common violations, you get a sense of what this policy is trying to combat. This policy prohibits creating multiple apps with highly similar functionality, content, and user experience. If these apps are each small in content volume, developers should consider creating a single app that aggregates all the content. So the intent is to purge out apps that are basically the same with superficial differences. While the intent of the policy is okay, the way it's being enforced is biased towards Euro-American sensibilities of what to expect in an app. And as they list above, they want apps that should provide users with a basic degree of functionality and respectful user experience. But the answer to that question is not the same in Africa as it is in the US. And this is something that we learned directly through working with our language communities. In our case, the calculators that were being pulled were the Adlam specific calculator and the full-featured multi-script calculator that includes Adlam, Unco, Arabic, and Latin numbering systems, as well as unit and currency conversion features. The standalone Unco calculator, however, was not being pulled. So right away, the logic behind the apps being pulled did not line up with the language of the policy. According to the language of the policy, you would expect the standalone calculators to be the ones pulled. When we developed the multi-script calculator, we actually had intended to deprecate the standalone calculators. But as we were exploring that option with our language community contacts, we opted to preserve them. But the one thing that is clear is that the reviewer was not familiar with the content in the app, nor the needs of the audience that the apps are designed for. In the years that we've been making apps for West Africa, these are a few things that we've learned. For each app that you make, there's potentially 3 different target audiences. There's the diaspora, there's the people on continent, and there's young students. And each one of these audiences approaches the app with a varying level of familiarity. The diaspora is more familiar with mobile technology and very comfortable with the design language. People on continent can vary in their familiarity, and as a result, it's best not to use a lot of gestural navigation or complex menu structure, and if you do, it's best to have some amount of redundant explicit navigation as a backup. This may appear as low quality as compared to a modern Western mobile app, but is that way by design. Finally, people are searching for apps specifically based on language and script identification. So an app simply called Calculator will not reach people in the same way as an app called Kimirgal Adlam. So to return to the story of our app, we ended up filing an appeal explaining our experience and the needs of the audience as best we could within a 1,000-character limit. And the appeal was reviewed, but ultimately the support team didn't fully understand what we were saying and we hit a roadblock. Fortunately, we were able to reach out to a contact in another department of Google, and that contact was able to get us an opportunity to send a much longer appeal to an internal review board. And after about 7 weeks, our apps were restored. But in this case, we were quite fortunate because we had an internal contact at Google. But if you see how this app could potentially affect a developer in Africa, they would not have that same level of access if they got trapped by the same policy. And in a similar situation, when we first released our Adlam keyboard app, we had a large number of positive reviews that were just purged overnight for violating content policies. The reviews in question were all written in Pular, including some from the Berries. We were given no particular explanation of what the precise infractions were, but again, our best guess is the reviewers didn't fully understand what they were seeing. Our experience thus far tells us that every gain is always a little bit tenuous. And when sensitivity to international norms are not present in every part of an organization, then by default the assumptions that will be made from a Euro-American perspective. And these assumptions most often will lead to the most underrepresented language groups to be left behind. And while these might all seem like minor frustrations, these kinds of roadblocks and regressions are persistent and cumulative, and if left unresolved, they propagate as technology moves forward. Let's take, for example, Yoruba. Yoruba uses the Latin character set with some unique accented character combinations like both a grave and a da accent on the same letter. But it's nothing complicated. And while most system fonts have ensured that those combinations work, as seen on this website on the left, in 2020 you can still stumble into what's seen on the right. The missing character combinations are falling back to another font. And this is a relatively easy thing to fix, but it persists to this day. When the concern was adding Yoruba support to a handful of system fonts, that was a manageable task. However, with the introduction of web font technology, the issue has now exploded to hundreds of broken fonts. Google Fonts is the most accessible web font service and therefore the likely go-to option for most people. Unfortunately, scrolling through the Google Fonts collection, one would be hard-pressed to find a font that can render this Yoruba name properly. So while it should have been easy to bring Yoruba speakers along for this improvement in web technology, we've actually left them further behind. So the case with web fonts is a relatively simple one. But to help illustrate why all of this is particularly important for scripts like Adlam and Unco, I like to show this timeline that we developed a few years ago. And this shows the chronology to internet adoption in the United States. And the key thing to see here is that when the internet came along, we had already institutionalized a lot of things like literacy, education, and infrastructure. When you compare that to how things are unfolding for newer writing systems, you see that all of this activity is occurring concurrently. This means that the internet is playing a much larger role in how these scripts are becoming established. So when we have even a year-long delay in adding support for our writing system or a regression along the way, all of that prevents young scripts from gaining a foothold in a meaningful way. So none of what I've discussed thus far is meant to devalue the amount of work that has happened thus far to bring underrepresented scripts into the fold. We're also not blind to the fact that ROI and business plans and resource management play a big role in setting priorities. But the thing is, the effectiveness of script encoding initiatives means increasing the scripts that are going to be added are not ones that are well established. And this has largely been due to forces that supersede the collective agency of those underserved language communities. So in light of this, moving forward, it would be nice to see the following things. Firstly, start assessing the effectiveness of internationalization efforts using functional metrics rather than the completion of discrete tasks. Secondly, providing methods to language communities and interested third parties to make improvements and bridge gaps. It would be good to always ensure third parties had a reliable way to provide things like inputs, methods, and fonts. Also, when your software service doesn't know the answer, rather than being prescriptive, request input. For example, when things like Chrome's page translation service thinks Yoruba is Vietnamese or Pular is Finnish, give the user the option to correct it rather than insisting on the wrong thing. Or when YouTube doesn't know how to auto-generate subtitles in Adlam or Co., at least provide the option and then request that the user provide their own subtitles. It actually makes things easier on everybody. And then finally, broadly recognizing that internationalization is not just rendering type and dealing with language, but also understanding how the needs and cultural norms of a language community affect how that technology is being used. After all, what is clear is that when the next technological disruption comes, and it will, encoding alone doesn't save a language or a writing system a seat on the ark. Thank you all for listening. Take care.